Hello everyone. Today I will discuss the code forces around 891 Div.3 problem, which is power of points. Okay, so this problem was really a nice problem. So you are given n points with integer coordinate x1, x2, xn, which lie on a number line. Okay, so we can consider this as an array having n number of points. Okay. Now for some integer s, we construct segment. So now it has been stated that if we consider any integer s, then then we construct segments using the elements of the array. If we consider this as an array, like this sx1 sx2 like so on. So if xi is less than s, then the segment will look like xis. So if the corresponding element, suppose if the s is greater than the corresponding element of the array a, so the segment will be obviously like this, and if it is greater than, then the segment will be like s then x. Okay, so that's quite obvious. Now, what has been stated that is segment A comma B. Suppose if we consider segment A comma B, then it covers all the integer points between A to B inclusive. Okay. So now we define the power of a point P as the number of segments that intersects the point with coordinate P. Okay, denoted as FP. So suppose uh, if we consider a point P, okay, then and we consider we have generated the segment corresponding to a number s using the elements of the array like this. Then the power of point p is the number of the segments, means the number of the segment in which the p lies. Okay, we can say the number of segments that intersect the point with coordinate p, so that is fp. So our task is to compute sigma fp, where p can be anything between 1 to 10 to the power 9. So basically we have to sum up for all the p between 1 to 10 to the power 9. Okay, for all s belongs to x1 xn, that is the sum of fp for all integer between 1 to 10 to the power 9. uh, I will when I will just explain this, then you will be clear with this question. Okay, so just consider that this is the array. This is the array A. Okay, and now if I choose s as 5, okay, so what would be the segments? I have already explained the segment will be generated like this, and you can see uh, first of all the number is 1, so obviously 1 is less than s. So first segment would be this. The second segment would be, you can see 2 comma 5. Okay, the third segment would be 5 comma 5. The fourth segment would be 5 to 7, and the sixth segment would be 1 comma 5. Okay, so basically this is the segment corresponding to only number 5. Okay, and now we have to do this for every integer in this array, like 1 2 5 7 and again 1. Okay, we have to generate the segments corresponding to all the number. We have been shown here how to generate the segments corresponding to a number. Okay, so here the s was 5. If I have chosen s is equals to 5, then these are the segments generated. This will be the segments generated. So now if I say, if I say what will be the point, since we have to sum up the power of points from for all the points between 1 to 10 to the power 9. So if I say which points will contribute to the uh, this function. Okay, means which points will intersect with the segments corresponding to s is equals to 5. I mean that. So obviously, if I just sort it, you can see 1 5, then 1 5, then 2 5, then 5 5, and then 5 7. If I have sorted this, So I can say for this segment 1 comma 5, all the numbers from 1 to 5 can lie in this. Now for the second segment again, all the numbers between 1 to 5 can lie in intersect with this segment. Now for the third segment, all the numbers between 2 comma 5 will lie in this segment. For the fourth segment, all the number it is only one number 5, and for the fifth segment, all the numbers between 5 to 7 will lie in this. So I can say, what I can say, the number of the points which intersect with this segment is obviously 5. 5 minus 1 plus 1, I can say. Obviously in this also I can say 5 minus 1 plus 1, it is 5. Again it is 4. 5 minus 2 plus 1, it will be only one number here. And 7 minus 5, it would be 3 number, 3. So I can say, then if I sum up this, I will get 18. Okay, so I have just modified the question, simplified the question. I can say that we have to consider every number in the array as s. Every number as s means we have to uh, find. Suppose if I consider 1 as s is equals to 1, so I have to generate all the segment in this manner, which we have discussed. And now we have to find the number of points which intersect with this segment. And I have also discussed how to find the number of the segment. Basically it is the summation of the differences between the range LR, okay, of each segment. So let's discuss the example one. So for one, for s is equals to 1, here it has been very beautifully explained. If s is equals to 1, if s is equals to x1 is equals to 1, then the segment will be 1 comma 1, 1 comma 4, and 1 comma 3. Okay, so obviously the number of points in this is 1, in this is 3, no, it is 4, and here it is 3. Okay, so if I sum up this, the number of points would be 8. Okay, for now if we consider 4, if we consider s is equals to 4, here it has been given s is equals to x2 is equals to 4. So the number of segments will be, the segment generator will be 1 comma 4, 4 comma 4, and 3 comma 4. Now the power of point, which is basically the summation of the points in each of the segment, it is 4, then it is 1, then it is 1, and here it is 2. So if I sum up this, the answer would be 7. You can see here it is 7. Now similarly for s is equals to x is equals to 3, the segment should be 1 comma s, 3 comma 4, and 3 comma 3. So the similar way it would be 3, then 2, and then 1. Obviously if I sum up this, the answer it is 6. So I hope the question is clear now. Let's move on to the solution part. So these were the test cases. So let's see the what is the idea. Basically, I have modified the problem, simplified the problem. Since we have to now, I am not going in terms of the power function like this, the power of the points. I will just explain in the simplified manner, the question in the simplified manner. Okay. So I am just discussing what we have to find in each of the test cases. Now, since we have to find the summation of the since we have to find the summation of the number of points that intersect with this segment corresponding to a number s in the array. Okay, s in array. So we have to find the summation of number of points that intersect with the segment corresponding to a number s. So basically, we have to generate all the segment corresponding to a number s in array A, and we have to sum the number of points in each of the segment. That's what the question is asking for. Okay. So if I consider the example one, the array was 1, 3, 4. I am taking that in sorted order because it would be much easier. So if I choose s is equals to 1, the segments are 1 comma 1, 1 comma 3, and 1 comma 4. So we know that if the segment is L comma R, then the number of points in that segment will be R minus L plus 1. Okay. So the number of points intersecting the segments 1 minus 1 plus 1, using this formula R minus L plus 1, we know that the number of elements in a range is R minus L plus 1. So I can say that the number of elements in this range is 1 minus 1 plus 1, in this is 3 minus 1 plus 1, and in this 4 minus 1 plus 1. That's what I have done. Okay, so I have got 8. Similarly, I have to do this for 3 also and for 4 also. Okay, and we would get this 8, 876. Okay, 876. Now, but one thing you should observe, that if I just generate this segment for each of the number, then generating the segments would take big O of n, and since we are doing this for all the elements in the array, so it would be big O of n square solution for no doubt. Okay, so how to optimize this? So we would just think of some pre-computation. Okay, now observe one thing. Now observe one thing, that what we are doing for every segment for a particular number s. Okay, particular number s in the array. We are just taking difference between every numbers in this array with s. Obviously, what I am doing, if I just uh, if I am considering s is equals to 1, so what I am doing, that 1 minus 1, 3 minus 1, and 4 minus 1. I am just taking the summation of them. So I had just written that only. We are just taking difference between every numbers in the array with s and summing them. So suppose if k number of elements in array is less than s, I am considering that a number s in the array, means I am obtaining the answer for a number s in the array, and rest are greater than k. So we have assumed that the k number of elements in the array is less than s, and the rest would be obviously greater than s if I consider the sorted array. Then the segments will be like a0 comma s, a1 comma s, means the segments corresponding to the number s would be a0 comma s, a1 comma s, because this would be less than s, so it will come before s. Then a comma k minus 1 comma s if I consider zero based indexing. Now, from the number between k to n minus 1, s would come before ai. Okay, so s comma a k, then s comma a n minus 1. I hope I am clear till now. Now, so for number s, the answer can be obtained by summing the number of points in each of the segment. I have already said no, that the for a corresponding for a particular number s in the array, we can obtain the number of points which intersects would be the summation of the points in each of the segment. So it would be like this: s minus a0, then s minus a1, then s minus ak plus s of ak minus s, and so on. Okay, so you should observe that till the key elements, for the first key element, I have what I have assumed, the first key elements is less than s and the rest will be greater than s. So obviously it would be in this pattern: s minus a0, s minus a1, and s minus, and after that you can observe ak minus s, means s will be obviously less greater than what I said, s will be obviously less than ai for all the I between k to n minus 1. So we can say that s will be greater than equals to ai. Uh, Let me write like this: ai k number of times, and is smaller than ai for n minus k times. Okay, so so now, clear indication is that we can obtain a formula for this. So the answer can be obtained as follows: k into s. Since k is the number of elements less than equals to s, so k into s minus. You should observe that how many times this s will occur before ai. Obviously, it is k times. That's why I have written k into s. Then minus summation of elements less than equals to s. You should observe that what are all these numbers: a0, a1, then ak minus 1. Obviously I am doing the summation and then subtracting. That's why I have written this: minus summation of elements less than equals to s. Then how I can obtain the number of summation of elements greater than s? Obviously it would be total sum, means the total sum is the summation of all the elements of the array minus sum of elements less than equals to s, which I can obtain using prefix array in big of one time. Then n minus k is the number of elements which would be greater than s. Obviously that number of times s will be smaller than the ai. Okay, that's why I have decremented n minus k into s. So this sum can obtain in big O of 1 using prefix array. Only thing left is to obtain the number of elements less than equals to s in array A. So that's why I have sorted the array no. So for this we have sorted the array A for every s in A. In array A, the number of elements less than equals to s will be the last index of occurrence of s. So for this I will just explain. Suppose the So if I just maintain a map, okay, so what I can say that when I came at index 0, so the index of occurrence of 1 would be 1. When I came to index 2, then it would become 2. So the last impression of 1 would be 2. So that's how I can obtain the last index of occurrence of s. And y plus 1, because I am following zero based indexing, so the last index of 1 is 2, but obviously I know that all the elements less than equals to 1 is 3. That's why I would have 2 plus 1. Now I hope the approach is also clear. Let's move on to the code part. I have already taken the input. Now I will take the array, and before that I will just take a sum variable, which is the total sum. Now I will just one thing I should just tell you that here the numbers are in not in sorted order, but what we are doing in our solution is that we are sorting the array, so we have to return the answer corresponding to this array only. So that's why I will have to also store the index of each element. That's why I am creating another vector. Let's name it as bn. So I can say vi is equals to, I will also take care of index. Okay, and let's create another answer, which will be the final answer corresponding to the numbers in the array we have been given. Okay, so now what I will do is that I will just sort. Here all is the macro I have created. You can see x dot begin, that x dot end, basically it is b dot begin comma b dot end. Now I will go to every element. One thing I just forgot to, we have to, since we have to also find the last occurrence of every element in the sorted array. That's why I would have to maintain an unordered map. MP of b of I dot first is equals to uh, b of I dot, sorry, it is I. Now, so when we iterate from the left to right, obviously it would be set because the elements are in sorted order. Now the index, the number of elements less than equals to ai, where ai is stored in vi dot first because I have sorted it. So it would be uh, what I can say, mp of v of I dot first. Now what I will do is that, sorry, it was vi dot first. One thing I also forgot, I have to also maintain a prefix array, which will store the sum till index I. So pre of 0 is equals to, I will initialize it with v of 0 dot first. Okay, then I hope now I have obtained everything I require. Now, uh, since the index in the original array would be stored in the vi dot second, so I can say int is equals to vi dot second. Okay, basically the final answer would be answer of int equals to just I will use the formula I have just created, which is the k into s minus sum of elements less than equals to s plus total sum minus sum of elements less than equals to s. So k into s, k into what is s? Vi dot first, our number is s. Okay. Then after this, minus sum of elements less than equals to s, minus sum of elements less than equals to s. So pre of what I can say, pre of k, pre of k. But wait, one thing I should also tell you is that if k is the number of elements, since uh, for a range r l comma r, for a range l comma r, the number of elements would be r minus l plus one. So you should observe that one would be sum how many times. If we consider k segments, then it would be add for k number of times. That's why I would have to just add k also to it, and after this I will have to in this for this also I will have to add n minus k explicitly. Okay, so prefix of k is the index of the last occurrence of this elements. Which element it is? As here is vi dot first. Okay, so I would have to just add k plus 1 because I am following one page indexing. One page indexing. So k plus 1 would be the number of elements less than equals to s. Now total sum minus sum of elements less than equals to s. So the total sum was is stored in sum, and then sum of elements less than equals to s was can be obtained like this. Okay, now I can say that n minus k minus 1 would be the number of elements greater than equals to s. So I can say vi dot what would be the contribution of them, vi dot first. That number of times s will be smaller than the corresponding ai, so I would have to just subtract this. And now finally I what I have told you that n minus k minus 1 would be the number of ones. Since why I am adding this k plus 1 and n minus k plus 1, you should be clear with. If the range is l comma r, so obviously the number of elements in that range is l minus r plus 1. That's why I am this one would comes k times if the number of segments is k. That's why I am adding this k plus 1 and n minus k plus 1, n minus k minus 1. Okay, so yeah, that's all about the code. Now I will just print it in present ip answer cout ip. Hmm, let's run it. So here it has failed somewhere. Let's see. Prefix of k. Okay, sum minus prefix of k, sum plus I have obtained it sorted. Then prefix I. Okay, vi dot first, there is no problem here. Then mp of vi dot first is equals to I. Then okay, int k is equals to mp of vi dot first. Okay, so So it should be k plus 1, no? K plus 1 will be the number of times s will come, and n minus. Uh, okay, I hope this should be clear now. Yeah, it has got passed. So that's all about the problem. Talking about the time complexity, we can just say that we are just sorting, so it would be n log n, and rest all the time I am just performing all the operation in big O of n times. That's why I can say that the time complexity would remain big O of n log n, and the space complexity, obviously we are taking array and the prefix array, so it will be big O of n. So thanks for watching.